Today we are adding and animating a score label to our snake game. By the end of this video we should have something like this. Pretty much we're showing the label on top, and once we eat the food it gets scaled and randomly rotates. So let's get started. Let's open up our main. Last time we added these shake effects and scale effects. Those were added to our end game screen. And today what we want to do is, first of all, we need to draw our score. Before we start doing any animation, we first need to figure out how we can draw it. So let's add our draw score function and think about how we want to approach that. First of all, we need some array saying that, hey, score text, let's make it a buffer of 64 symbols, even though like that's a lot, maybe like 32 should be fine. Then we need to calculate our current score, or in other words, the length of our player snake. So the score itself is going to be the length of the array game player tiles. Next, we need to somehow print the score into our score text, and we can do that using printf into score text, size of score text. We would like to say something like length and provide the score. So now score text contains the string length, and this ZU is substituted with our size t score. Finally, we need to output it. So let's do that. Draw text, I think it's extended. Font, we use our Kate font. Text is our score text. Position, let's do it something like draw position, and define it for now as an vector of x and y being zeros. Font size, score text font size, let's define that as well. Size t, score text font size, let's do 32, same way as our length of score text array. Spacing is 0, tint is white as usual. I don't have my alias, which will be, as usual, some cmake and build. So it got lost along the way. Alright, so we can see that our score or length counter is currently sitting at the top and at the top left corner. This draw position sets it to be drawn there in the top left corner. So we can easily position it in the middle, saying that, hey, we have game width, we can do divide it by 2, and now the starting position of our score is actually in the middle. But we would like this text with the score label to be positioned so that it's in the middle of the screen. We can probably do something like this, do some small padding from top so that there is still some space, yeah, between the snake, maybe even like 4, something like that. So here we need to somehow adjust our X so that the label is positioned in the middle of the screen. Right now the start of the label is in the middle, but we want the middle of the score text to be in the middle. How can we do that? We can say that, hey, score text size, I think we already did that before. We can measure text using our Kate font. score text, text font size, spacing is 0. So it gives us the dimensions of our label. And then we can simply say that, hey, let's shift it to the left by half of its width. Right, so score text size x divided by 2. If we run that, we have our label where we want it. Right now, the biggest problem, so to speak, is that this label is kind of dull. It's updated instantly. There is no feedback the same way as done on our game over, where the screen shakes and scales. So that is exactly what we want to do next. We would like to introduce some sort of score effect here. Right? We don't have that yet, but we would like to have it and apply it to our drawn score label. So let's do that. Let's first define our new structure, which is going to be responsible for ScoreEffect. We would like to have some scaling and some angle so that it rotates a bit. And then we can add some duration. So as you can see, our ScoreEffect is going to be some linear animation, same as ShakeEffect. It runs for the duration that we set, but our scale effect, I think it was ease out, right? So it was at first really quickly trying to reach the target scale. So the first initial steps were big, but the closer we get to target scale, the slower it became. So ScoreEffect, first of all, we need to give it some defaults. ScoreEffect is going to be what? It's going to be duration of 0, so it's not enabled yet. Angle is 0, we do not rotate the label, and scale is 1, so that there is no scale yet. Then when we draw the score, we can pass it ScoreEffect. All right, so what can we do? We can probably, yeah, just apply. Well, let's rotate. Given an effect, we already have some angle. We are going to rotate on Z, so Z-axis, in terms of 3D, is actually pointing into our screen. So that's the axis along which we're going to rotate. And we can also, I think, scale. As we're scaling in 2D, we need to scale on the X and Y. So we can say scale for X, we can scale for Y, and keep set as 1. Let's see how that works. So nothing really changed. Let's change a bit the defaults for now. For example, I want to have an angle of 10 and scale 1.3. If we run it, we can see that first of all, the transformation was applied not only to our score, it was applied to everything, like the whole board, the tile grid, snakes, everything is being drawn with those angles and scale effect. What we can do is we can say that, hey, we should really apply these effects only in terms of draw score. So we can keep or push our current transformation matrix onto the stack and then pop it back once we're done with all the score drawing, so that it doesn't affect any other draw calls. If we do that, we can see that tile is once again drawn correctly. Our snake runs behind this score label, but the label updates nicely. But the thing is that scale worked nicely. You can see that the text is bigger, but the rotation is applied from 0, 0, top left corner. So the origin that the rotation against was at this 0, 0, and we want the rotation origin to be, once again, this middle of our score text, so that whenever we rotate, we are just rotating based on this origin in the middle of the length, so that the label stays pretty much at that same space. So what can we do? Because this rotation is currently being done at 0.00, we would like to shift the origin. So we can say that, hey, we would like to have a new origin. How do we calculate that? Let's see. So it is going to be just the middle of our screen, right? It's the middle of our screen, and y is our 4 plus score text size y divided by 2. Right? So this one brings x exactly to the middle. All right, to have it run, we can mark it maybe unused for now. So we would like our origin to be right here, which is exactly middle of our game field, and it is this tiny shift from top, like 4 pixels, and then half of the height of the score label. That is exactly what we did here. And now we can apply it by first applying translate, where we move it to the new origin x, new origin y, and c is 0. So we move origin by x to the right and by y below. We apply the rotation. Based on this new origin, we apply the scale effect, and then we need to revert our changes and draw the text as before. And now we can see our label being correctly scaled and drawn with an angle based on this origin, which is somewhere like right here where my mouse pointer is, in the middle. Let's default to correct values in our main. When we run it, everything is fine. And next we need to do what? We need to update our effect based on delta time. So let's introduce another function, update ScoreEffect. We're gonna update ScoreEffect based on delta time. Update ScoreEffect. First, we need to check whether duration is greater than 0, and only then we can decrease duration by delta time. Check if effect duration is less than or equal to 0 or else. So if it's less than or equal to 0, then we need to have our label back at its position, meaning that duration is 0, effect scale is 1, and effect angle is 0. So these look exactly as our defaults in main. And otherwise, we need to say that, hey, I'm going to calculate how much I have transformed, or how much time has passed for t for the given duration. So the whole score effect would take some amount of time. So let's define it, say score animation duration, let's say like 1/3 of a second. So it means that if I take my duration and divide it by score animation duration, initially initially this effect duration will have the same value, right? So the t, which we would like to be from 0 to 1, needs to have 1 minus this. So initially the duration is the same, so this division results in 1, and 1 minus 1, t ends up being 0. And once the duration is almost 0, this division is almost 0, it's nearing the 0 value, so t is really close to 1. And what we want to do is we want to update our scale as lerp 1.3, I think we would like to, based on this t, and we want to have angle as lerp given our current angle value, we would like to reach it 0 once t is 1. What is a lerp? It's a function, we can grab it from math, and it linearly interpolates between two floats. So we have some start value, end value, and the amount. The amount is from 0 to 1, so whenever amount is 0, we get start, whenever amount is 1, we get an end, and whenever amount is between 0 and 1, it actually interpolates the value between start and end based on this percentage. You can think of amount as how much we have moved from start to end based on this percentage from 0 to 1. So in this case, whenever we start our animation, we are going to be pretty close to this 1.3, because t is pretty much 0 in the beginning, so it's going to be 1.3. But as t grows, we're going to interpolate, in other words, move from 1.3 towards 1.0, and eventually reach that 1.0 value. Same for angle. We will define some angle and move it towards 0 so that we negate the rotation in the end. If we run it right now, then we won't see anything yet, because we do not set these values, the duration, the scale, and angle. And we can do that whenever we detect that we have actually hit the foot. So we can say that ScoreEffect duration is going to be this duration value. ScoreEffect angle is going to be some random, let's say from -10 to 10, and ScoreEffect scale is going to be like 1.3. So it's going to be the same as this value. We can extract it as constant as well, but yeah, let it be. So if we run it and try to eat this food, bam, you can see that our animation works now. Let's see. Yeah, we're getting different rotation angles, and that's great. So this is pretty much it about the score and animation, but maybe we can do one tiny thing as well, which I don't find that great, but it might be useful. You might find it useful, so I think it's worth showing. So let me show you something. So whenever we draw TileGrid, we are drawing tiles with the color based on the tile state. And what if we detect that row is the same as game, food, position, row, or column is the same as game, food, position, column? We can maybe say that, hey, R plus 10, G and B plus 10. So we would like to highlight the row and the column where the food is to help the player move towards the food. Right now it complains that our row is size T and food position row is integer. We can of course do the correct way by checking that if game food position row is greater or equal to 0, and then cast it to size t, and that would work. And we just need to put extra parentheses so it no longer complains about it, but that's just too long and for our small game that's an overkill. So let's do an easier way, something like this. Should work as well. So once again, we're detecting that this current row or column, that's where our food belongs to, and we would like to highlight the colors a bit. All right, so it seems that column and row are a bit highlighted, but yeah, it's kind of broken. Why is it broken? It is because the colors should be in range from 0 to 255, and by blindly adding 10 we are overflowing those values. So really we should say that, hey, let's clamp this color R plus 10 from 0 to 255. Same here, into the RG and B, so that it never goes over 255. And now we can see that, hey, the food is shown correctly and the rows and columns have a bit of highlighted color. I'm not entirely sure whether that's good looking, useful, but I wanted to show it to you guys so that you know it's possible to do that kind of thing, that kind of helper to our player. Alright, so that's pretty much it about the gameplay, about the score, the end game. And for the next few videos, we're gonna work on some post-processing effects using shaders to add that retro feel. I hope you like this kind of videos, so please do like the video itself. If you like this kind of content, would like to know more, see more, please do subscribe to the channel. It helps me greatly. Thank you very much, and I'll see you again. Bye.